So the presentation today is Solr Troubleshooting Treemap approach. My name is Alexandre Rafalovitch. I work for United Nations at the moment, but you hear it first. I'm about to start a search here consultancy specializing in troubleshooting, support tools, user onboarding, and things like that. So you may know me from Solr Start resource website. If you don't, check it out. You'll find it useful. And my views here do not represent United Nations. Yes, I'm sure you know the standard disclaimer. Okay, so let's talk about Solr troubleshooting. I'm really glad to see so many of you here because that means the questions on the Solr user mailing list will be a lot more interesting after you apply this approach. And hopefully you'll be able to solve a lot of your problems yourself. So let's not start from troubleshooting. Let's start from the magic of creation. And as Arthur C. Clarke famously said, is that any sufficiently advanced technology is indistinguishable from magic. And Solr, especially Solr 5, has been getting very advanced. And some of the things it does are pretty hard to distinguish from magic. The new startup command line is a good example of that. So you run one small command line, bin Solr start, example minus -e tech products, and you get a lot of things happening. Pure magic, really. You know, you start the server, it starts the server, it sets up the collection, it populates it with documents, it commits those documents, and hopefully at that point you're ready to profit from it somehow. With so many of you here, I don't dare to give a standard use case. I know there are so many. However, the magic has its price too, right? Imagine it's somebody else or some other script that run the command and you don't actually know what the command is. Suddenly you have a lot of questions, right? You're going, well, what port is the server running on? What's the collection name, right? Is this collection using a static or dynamic schema? If it's using dynamic schema, it's actually schemaless. Which directory are those files residing in if you want to change them or double check them? What directory is the data residing in? Could be common location or it could be a custom location. You know, what documents have you populated already? Is everything committed? And of course, the question that everybody really wants to ask is, why does my query not work? You know, so that's where the troubleshooting starts. You know, you have a problem you're trying to figure out, and most of the time most of the people don't know how to go about that. So this presentation is trying to give you more a mental sort of process of how to do that, more than very, very specific technical details, but I'm going to touch some of those as well. So the troubleshooting process I'm going to describe, it's important to understand it's not a linear process, and it's not really taught often, and when it's taught, it's often not taught too well. It's kind of, okay, here's an example, fix it kind of thing. So, my experience, I've been creating some projects based on Solr, and I've also done 3 years as technical support for a very complex product back in the past, BA WebLogic, for those who remember. So those 3 years have costed me some of my hair, but have also taught me the skills that most of the developers don't have. And those are the skills I'm applying to my own projects and also happy to teach to others. So I'm writing a book for O'Reilly. It's called Solr 5 Troubleshooting and Maintenance. The book is coming soon-ish. Solr is quite a moving target and turns out to be trying to describe all the possible things to troubleshoot with Solr, and especially maintain Solr is a lot more difficult than even I anticipated. So it might be Solr 6 by the time the book comes out, but it's coming. Now, it's hard to explain the book in 40 minutes, so I'm going to give you a slightly simplified mental model based on a Treemap approach, which is covering same concepts, but in a slightly more easier to understand on a slide form way. The mental model is based on something called root cause analysis. Some of you may know that terminology. It's used in other fields. It's not specific to Solr. It's not even specific to software engineering. And it's actually come from a fairly old book called The New Rational Manager, which is a really good read. I recommend it if you can find a copy. Would probably be quite cheap by now in second hand. So what's a troubleshooting tree map? Well, first, what's a tree map? So you might have seen this sort of visual representation. And in this case, a very good example is if you run out of disk space on your computer. Those of you with Macs probably nodding right now with the smaller hard drives. But and you look and say, how much disk space do I use altogether? And then you say, okay, well, if I split it into blocks, usually high-level directories, which one takes the most space? And then you drill down until you figure out that, oh, there is this video of Aunt Mary's wedding from 10 years ago that I've put there 10 years ago and been copying ever since, and now it's taking half of my drive, kind of thing. So the same kind of approach you can use to troubleshoot any products, but Solr specifically. And what you do is you establish your boundaries, and your first set of boundaries will be very generic. And then you split the problem, hopefully right down the middle, though realistically that's not always possible. But you split the problem in two, and you identify which of these parts, of two parts, is actually relevant, right? Which is the one that's where your problem is, and which is the part the problem is not, right? And then you zoom in into this part, and that's your new boundaries. And then you do this process again and again and again until you actually got to the point where you know what's happening. You're not just looking at it from a very high view and going somewhere in there is a problem. You actually know where it is, okay? Now, to establish the boundaries, we look at 4 terms, and one of them is more important than others, and the other 3 are kind of supporting. Now, these are not fully distinct terms, but they are the way you sort of think through the problem, and they help you to narrow it down. So when you look at the problem and you ask those questions to yourself, you get the hypothesis to test and so on. So those terms are, as you can see here, identity being the most important one, and it's supported by location, timing, and magnitude. Okay? And I'm going to go through each of them individually so you can understand how that applies to Solr specifically. So the identity as a boundary. So identity is an action we want to accomplish or problem we're trying to solve. Okay? And here's an example, for example, that came from the mailing list a little while ago. Somebody has said that echo params parameter gets duplicated with an example config. Sometimes. They couldn't quite narrow it down. It just happens sometimes. They couldn't figure out when it happened. But it was causing some minor problems with the client because they didn't expect that parameter being twice, and it complained about it and so on. And I was seeing that for my own examples when I was starting the book. So I started to drill in, and I actually applied my own techniques to that. And turned out to be that that initial definition was incorrect, effectively. It was both too narrow in some ways and too general in another. And the final definition was that any query parameter, so not echo params, any of them, that's also in the request handler's default would get duplicated. And that makes it a lot easier to troubleshoot, because if it's any query parameter, you know it's not something special about this parameter. You know it's something just about the parameters are handled in general, right? So it eliminates a lot of very specialized subsystems, right? But it also showed that because it's any query parameter, the impact was actually quite significant. So when I've done my analysis and I upload my analysis, put my analysis in Jira, Hoss himself actually looked at it and he said, oh, it's an evil freaking bug, because it was quite deep in the system and it was affecting a lot of random places in a lot of not obvious ways. And the solution was like 4 lines code change. It was just stop the duplication, right? So the fix was trivial, but to find it, you had to be logical and systematic in how you were troubleshooting the problem, and some debugger. Now, don't despair here. This gets easier with practice. I can tell you, like, my first year of tech support was pretty difficult until I figured out this sort of approach. And then you really get it going, like you start thinking in the particular way that allows you to troubleshoot this. So that's identity. So it's supported by the other three. So let's look at what location means for Solr. So location for Solr is a place or component where this problem actually occurs. Now, if your problem is that Solr cannot find customer records, you don't actually know where the problem is. It could have been indexing. It could have been search, right? You have to split that into two, and you have to figure out if it's indexing, well, maybe the record was never sent to Solr if you're coming from a third-party system. Maybe you use the wrong handler, so the parameters are all wrong. Maybe the schema definition is incorrect, and so on. You might have used the wrong pipeline, right? But first you need to decide whether it's indexing or searching. If it's searching, it could be too restrictive, so you have some extra filter queries you forgot about, or it's too permissive when your result is actually page 100 of your results where you expected it to be top 1, and so on. Okay? So the location would narrow down where the problem actually happens. Your definition will change. And of course, if you have Solr Cloud, then you have many more locations. You have the leaders, you have the follows, you have the... I can see somebody nodding at the front of the room. So yeah, so you get a lot more options where things could go wrong. Okay, so that's location. So let's look at timing. So timing is when or how often the problem shows itself, okay? And there are two aspects. There is reproducibility and there is onset, okay? And these are standard tech support questions. If you ever call tech support, they will ask you these questions because these are the way they isolate the problem, okay? And the reproducibility, can you always reproduce it? Do you hit a server with a particular command line and it happens every time, no fail? Ideal, because you can troubleshoot it, you can debug it, you can do all sorts of things, okay? What we often see is seemingly intermittent, as in it happens sometimes. Now this is useless, okay? It's useless not because it's not a description, but because it means you haven't identified what the trigger is. Because sure, something could truly be intermittent, like meteor hit the earth, the magnetic field changed, the bits flipped in a computer, and suddenly, like your drivers spontaneously change the content of a file. Maybe. Very, 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 very unlikely. What's more likely is you haven't figured out the trigger, okay? So what you're trying to do is you're trying to get from seemingly intermittent to this next one, which is on trigger X, for example, such as on commit, on a document larger than 100K, on a document that's missing a value for a particular field, on a document that has an ID that's already present in a database, on update, something, right? Once you have that trigger, it's nearly as good as always. It means it's harder to set up a replication case. You may need to follow the sequence to get to that point or whatever, but it's good, okay? So that's one aspect. So if you're going to a mailing list and you're saying, I've got this intermittent problem, they're not going to be able to help you all that much. You need to do at least one more round of narrowing it down. The second thing that is very useful, and a lot of people forget to think about it, they say, I have this problem. The question is, well, how long you had the problem for? When did the problem start, right? And this repeated question often bring up and going, oh, I upgraded from Solr 4.7 to 5.3 and the problem started. Well, that's good to know, right? That immediately isolates, well, what changed? That gives you that change. Okay, so to be able to say that the system worked at time point X and does not work at time point Y gives you that window of changes. Whether if it's a Solr that changed, then it's what did the different versions have. If it's if it's not the Solr that changed but something happened, then it's was there an accumulated effect or was there a specific change somewhere else, which could be your ops have changed, upgraded a version of Java or something like that. Gives you a very specific time window to go and ask about. Okay? The second thing is, and it really throws everything away, is that the problem may have existed already, but you may have not seen it. It may have been shadowed by something else. Okay? So you're not necessarily expecting direct solution. You're saying what happened in the last 2 days. They're not expecting you to answer what happened with Solr. You if you can't answer it immediately, you need to broaden your search and say, what happened in general? And they may say, oh, we swapped out the hard drive for the logging subsystem. It's like, oh, okay, so maybe there was an interruption in log writing or something that triggered follow through and so on, or something else happened that shadowed the problem. The problem was existing before, and suddenly it shows up when something else gets removed, like a Jenga piece, you know. Okay, so that's timing. The next boundary is magnitude. So magnitude is what is the extent of the problem, and it's whether the problem applies to latest Solr or an old version. You know, when you ask a mailing list and you have like Solr 3.2, and you're asking for help on the mailing list, you need to say it's 3.2, unless you've tested it on 5.3 and it still happens there, right? Because something that affects that old version may not affect the new version. You kind of need to know that range. Or if it happens on 5.3 but doesn't happen on 5.2, that's the same. So you can see those variables kind of interplay a little bit. Okay? Can you reproduce it against the example schema? If you can reproduce your problem against the example schema, you will have people jumping up and down to help you, because they know what the example schema has. You know, they know the cross references, they know the kind of features that went into example schema. The further away you are from the example schema, the harder it is to troubleshoot. So it's in your benefit to think about the magnitude of the problem and say, I have this problem. Does it apply to this completely custom schema, or does it also apply to like a fully stock schema with this one change on it? And if you can narrow it down to that, then you're golden. Okay? And of course, again, with the Solr Cloud, is it happening on a single node or is it happening on the cluster? Okay? And the more standard recent configures, the easier it is to troubleshoot. There is also a corollary to that. The more standard the config is, if you think there is a big bug on it, it's usually not a bug. It's usually maybe you didn't understand the configuration, maybe there is a new feature, maybe something else. So it really helps to look twice. Unless it's a really, really edge feature and you suddenly want to use it and you're the first person to use it, then maybe. Now, the thing about the boundaries, you identify them. You don't just say, here's what happens. What you want to do is you want to say, here's what my here's the boundary divides two things. What your problem is and what your problem is not, right? I mean, it's a definition of a boundary, but I think it's worth talking about it because in my own mental process, whenever I make a statement, I will say, this problem affects Solr 5.531, right? My mind immediately goes, well, is it truly really affecting only 531, right? Yes, that's what I'm running on my system, and it's affecting that. But is it affecting 530? Is it affecting 521, other things? What is it not affecting? So if I can narrow it down and prove that it's affecting 531 but not 521, or 5152 as example here, and I've tested for that explicitly, that actually gives me a much stronger definition of a problem and much easier to troubleshoot. Okay? And this negation is a mental thing. You have to look at the problem and poke at it and say, I am saying it's happening during search. Well, am I sure it's happening during search? You know, am I definitely sure it's not happening during indexing? You know, and then you do a test case, you split it in the middle, and we're going to see how in a second, and test it. Okay? In a common example of saying, it's happening with my document. Here is a document. It's got 300 fields. It's failing somewhere in there. And you're saying, well, okay, but it's not happening with this other document. And it's also got like 300 fields. Can I isolate? Can I take those two documents and pare them down to one that works and one that doesn't? You know, and it might be actually 2 fields that's a problem, or 1 field that's a problem, or one document has 1 field but the other one doesn't have it. So by asking this not question and coming back and testing your own assumptions, you get a much tighter use case to troubleshoot. Okay? So let's have a look at sort of one way you split the subsystem. So say you start at Solr and something is happening and you're not sure what's happening. And you're not sure the start script was started in the way you understand what happens, because different parameters do different things and different operating have different things and so on. These slides will be online pretty soon. If you're desperate, I can send you a copy like early. You can contact me. But so what you do is you don't necessarily want to try to trace through the execution logic of the script, right? Because then you're making an assumption that every line you think you understand what's going on. No, you look at the ground truth. The script has to execute Solr process at some point. At that point, all the variables, all the system variables, all the defaults, everything will be embedded in that final execution command line. That's what you want to look at. You know, that's where you see the directories, whether they relative or absolute directories been used, whether they've been resolved properly against the correct base and all the rest of the stuff. That's your point of truth, right? So in Solr, if you actually know which port your Solr is running at and you have access to admin UI, then you just go and look in UI, and it will tell you which version of the Solr you're running. It will tell you which version of JVM you're running. You know, it will tell you what parameter command line arguments were passed to the JVM. So you get all of those things and so on. And then for the collection-specific overview page, on the right-hand side, there is an instance, and it will tell you the directories where that instance lies. In the latest Solr, because we are sort of transitioning to config sets and other things, when you use examples, they're not always in the same location. Sometimes they're in the server directory, sometimes it's in the example directory, sometimes for the cloud examples, it's actually a bunch of directories and so on. If you try to logic it out, it kind of gets confusing. But you can just go and look at the ground truth. Solr tells you, right? In admin UI. If you don't know on which port you're running, right? Or if you want to look in a different way, you can use operating system level. Operating system knows how you started the process. It has to, right? So on Unix, you just do ps command, and it will give you that whole big command line for the Java process, right? This is about 10% of that command line. So I've deleted a bunch of things. Okay? On Windows, you can use sysinternal tools, Process Explorer, which will give you information about the process, which includes the parameters as well. Sysinternals, in general, are really great troubleshooting tools. If you're running Windows, hopefully not in production, if you're running Windows and you don't use sysinternal tools, Microsoft tools now, you're missing a lot of useful ways to troubleshoot the system. Okay? All right. So that's sort of a high-level overview. So let's have a look at a couple of examples. I'm not going to be able to dig into really every possible way, so I just want to give you a couple of ways to think about the problem. And then, you know, the book, when it comes out, will cover more, and there are other resources I want to point to. Okay. So the way Solr works on a really, really, really high level is basically we index something, and then we search something. Right? That's kind of the way people, and in the beginning when people install their, like I would have said last year, collection 1, which is no longer true, but when people install their first example, they kind of think about it that way, going, I index something into Solr and then I search it, okay? So let's see what those two big blocks actually have. So we're going to start with indexing. Well, turns out to be indexing is actually a lot of steps, right? So when you make a request to index something, you choose your request handler, right? You, whether it's update or extract or a bunch of other things that map to those things and so on. Then you have to apply all parameters, and Solr is getting quite comprehensive in the way it allows you to supply all those parameters. The latest version has, what, 7 different ways you could provide those parameters. So more flexible, a little harder to troubleshoot. You can see the trade-off of that kind of thing. Most of them don't. Most of the people don't actually use shared param blocks. They are too new and not really documented. Most of the people don't even know about REST-driven overrides, which is a good thing to find out, but you may need to read JIRAs. It hasn't been documented yet. But those things exist, and actually they give you a lot of flexibility in configuring, but they make it harder to troubleshoot as well. So you have to figure out what's happening there. Once the parameters are figured out, the request handler is actually executed, and regardless of what kind of request handler it is, however it takes input in, whether it's PDFs or CSV or XML or JSON or whatever, in the end, internally, it will generate standard Solr document, which then goes into update request processor chain. Now, I don't know how many of you actually looked at the update request processor chains. They're kind of semi-hidden part of Solr, but the reality is that's where the work actually happens. And the reason most of the people don't pay attention is because there is a default built-in chain which executes if you don't define one, right? And it will do insertion into schema, it will do distributed processing, it will do all of that stuff. All of that stuff is actually update request processor chain, right? But in addition, things like schemaless and so on, which we'll see in a minute, also using update request processor. So that's kind of the iceberg part under the water of Solr. That's where a lot of work happens that you don't necessarily see. Update request processors are in the Solr config, yeah. But let's leave the questions towards the end because I'm happy to answer them later. Yeah, so, but most of it, if you read Solr config.xml, there is a lot of information there. If you just actually read it line by line, you will learn a lot about Solr. So once that's done, you map stuff to the schema field, also in the update request processor, actually. That's where it's happening. And then you have issues, whether it's explicit field, dynamic fields, whether they're copy fields, and so on. That's where you map to the schema. And finally, the documents need to be committed, and there is a couple of options for that. So when you look at this, when you say, oh, I indexed my document and something didn't work, this is very general definition. You can drill down and say, well, which phase did it fail in? And you can test each of these phases. You can split it and so on. Okay. So as an example, how do we discover the parameters, right? So we saw there are 7 ways to define those parameters. It's kind of complicated. Well, here's a little secret. I don't know how many of you noticed in the web UI there is a log section, but under the log section there are log level section. That is live. If you change a setting for the log level for individual element, it affects it immediately, which means you can go into a production or into your test system. You don't need to restart Solr. All you go in, log update processor is one of your update request processors that has to be present in every chain, and it actually spits a lot of information out if you look at it. By default, it logs at info level, and you can see here the difference between info level and debug level. So I just went into my live instance and I switched from null, which means default level, to trace, and suddenly I get a lot more information in Solr log. Okay? I can troubleshoot, turn it off, we're back to normal, back to no impact on production. Okay, so that's live. And you can see that in the first case on the info level, it logs the params that it's getting from the query. But on debug level, it will actually look at all the rest of the places where the parameters are coming from. By that point, they are aggregated together, and it will tell you what they are. Okay? There is also a secret API to get current config. Try doing it if you're running Solr 5.21, I think, and later. Try doing that. You will get like a huge file that. It's not secret. It's just undocumented yet. It's being improved on it. So, but I'm pretty sure it's used in production already by some people. And there is actually a lot more information under that. There is overlays. You can see what's overriding standard configs, what you can use particular components and so on. But it's not really documented yet. So this is just a higher level point. Okay. Now schemaless, right? A lot of people going, okay, I'm using Solr like I would use Elasticsearch. I'm using schemaless definition, and something happens, I don't know what. Well, the good news, Solr is not Elasticsearch. So our schemaless magic is actually defined right there in the Solr config.xml. This is about half of it. I've deleted like about half the lines so you can see. But you can actually just look at it and see what it does. You could see that, okay, we generate an ID if we need one. We log it. It goes to multiple nodes, and then at each node it does some processing. And then we remove the blank fields. We clean up the field names, replacing white spaces with underscores because we're not allowing white spaces in file names. That's not good. Kind of thing breaks other parts of the system. And then we try to parse booleans. We try to parse dates. We try to parse a bunch of other things. Here are all the date formats we understand, and so on. And then based on that, it will try to map it to the field types. So that's where the magic happens. So if you're not happy with the order in which it happens, fine, change it. If you have a non-standard date format, as long as Java can parse it, and Java can parse quite a lot of the date formats, fine, add it in, or remove the one that are causing you problems. It's all defined, right? And it's update request processor, just one of those. Okay, so that's an example. So let's have a look quickly at the searching then, right? So search, a query. Similar kind of thing, right? You choose your request handler, and we have a lot of problems with that. People come and say, hey, I'm doing something and it's not working. And then once you talk to them, they say, well, I'm executing my search from this third-party app. And immediately you're going, well, what request handler is the search-party app using? And which one are you testing it against manually? And lots of times turns out to be they're different endpoints. And because they're different endpoints, there are different parameters, and that's why they cannot reproduce it. Right? So parameters the same way, and then the actual search. And when you look at the books or when you follow the examples, it say, oh, you can search, or you can do faceting, or you can do statistics, or you can do debug, and so on. But in reality, that's actually defined as well. That's called search components, and we actually have a standard set of search components in Solr, right? We define it in the Solr config. Well, okay, it's commented out in the Solr config because it's default, but you can change it. You can prepend. You can add your stuff in the beginning. You can add your stuff in the end. You can redefine it. You can do whatever you want, right? Which means you can add and remove components and possibly troubleshoot them and so on. Okay? Then when the actual search is happening, you got the query parsers. And everybody knows about EDSMAX. If somebody doesn't know about EDSMAX, we are failing at our job of explaining Solr. But did you know that there are more than 20 of those different parsers? There is all sorts of things, right? And often if you're having a problem with a particular parser and you're trying to make it do something like really strange, like prefix search or infix search using standard parser, there is actually a solution with a different parser that will do it better. Okay? And finally, you have response writers, which is XML, JSON, but there is also Python, Ruby, PHP, Velocity, CSV, and there is a couple of semi-magical ones, which is schema.xml and xsort, and I don't think you can connect to them as easily, but they are there. They are for like special cases kind of thing. Okay, so let's have a look at an example. So Solr Tech Products example ships with a browse handler, which uses Velocity to render the UI and allows you to search for stuff and select things and so on. So in this case, I just use the browse handler and I said this is a test, and this and test as a capital, just to see what comes up. Okay? Now, how would you troubleshoot that? Well, you're like, well, I don't know. It's a UI, it's a Velocity, I don't know. Well, remember, this is Solr. This is a query line. And I said, look, you're outputting stuff as a Velocity handler. I don't want you to. I want you to output as XML. And I want you to echo the parameters. And I want you to give me debug query, to enable the debug for it. And instead of getting the Velocity output, you're suddenly getting XML output, right, with all the debug enabled. And what you can see, right, it's kind of, well, you cannot see, but I highlighted a couple of things. The debug is very complicated. You kind of need to have a bit of a, at least master's level knowledge of Solr, possibly PhD level knowledge of Solr to fully understand the debug output. But But you don't need to get to that level of knowledge for it to be useful. You can just see, in this particular example, it will show you every field that the query is run against. If you're expecting it to go against a different set of fields, you already know where the problem is, right? So just that list of fields is enough to split the problem into half. Okay, and you can also see that the test in some fields are uppercase and in some cases is lowercase, so you can actually see some of the processing that happens to get it there. Okay, a couple more tools and then we're done. So again, for search, also you can enable the debug. So the query component, facet component, you can enable them and so on. If you don't know how your stuff is processed, the analysis screen is really useful. You know, that's where we will send you if you're saying, I don't know how tokenization works, and you can enable the flag to see what happens deeper in. Okay, troubleshooting Solr Cloud. Well, Cloud adds many more locations, so good luck troubleshooting Solr Cloud because there is an exponential complexity increase. Try to reproduce it in a standalone instance. If you can, it's a lot easier. Okay, the tools do exist, something like Jepson, you may have heard of it, but they kind of require a PhD of their own. But the most important, the Treemap process is the same. You're still going to troubleshoot it in the same kind of way. Okay, so closing notes. Troubleshooting is both art and science, right? The art is the intuition kind of way to figure out what you're doing. But the more you apply the science, the more you sort of look at it and going, have I thought about location? Have I thought about magnitude? What is it and what is it not? And so on, the better you get at art. The more intuitive you become about jumping to hypotheses that you will contest directly and they will split the problem, or sometimes they give you the answer straight away. Okay? Remember the overall process we discussed and remember the boundaries. Most important, do not panic, bring your blanket and the rest of the things. Next steps. I have some resources for this and I have a mailing list at the solarstar.com. If you're not members of that mailing list, you may want to join. I'm going to start feeding a lot more troubleshooting ideas and examples and possibly use cases to it pretty soon. Solr user mailing list and archives are really good. If you're writing an email and you go through this process and you identify your boundaries, however far you can get, we're not expecting you to be perfect at this, but if you can just think about those issues, you know, your location, your magnitude, and test them, even the basic things, it would really simplify. It would really make it easier for us to help you to answer the question, because those are the questions we're going to ask you anyway. So that kind of speeds it up. Books, current and upcoming. Search engines, make sure to use the good keywords. Again, you know, if you narrowed it down to the update request process, obviously putting that keyword in makes it easier to search. And finally, I beg you, share what you learned. Because a lot of the problems, you know, you Google for it, somebody else writes, hey, I've done this thing, I hit this problem, that's my workaround. It's really, really useful. Okay, so we appreciate you doing it. Thank you very much. We are at the end. We don't have time for questions, which is not unexpected.